All right, in this video, we're going to discuss level curves. We're going to first discuss what they are, but then we're going to find a few things pertaining to them. For some fixed value, the first thing we're going to find is the equation of the level curve. Then, for some point on the level curve, we're going to find the normal vector, and we're going to find the tangent line equation for that point on the level curve. All right, before we get into it, if anything that we discussed in this video today is helpful to you at all, please leave a like, consider subscribing or leaving a comment as well. Thank you for watching. Let's get into it. Okay, so what is a level curve? So on the screen here, I have just a simple paraboloid. You can think of it as just kind of a hill, right? And as long as we're thinking of it as a hill, let's have a little guy right here. And he's standing right there, and we're going to put him on the hill. So let's put him right here. Why not? All right. So say that we asked him to walk uphill, then he might go this way. If we asked him to walk downhill, he might go this way. But what if we asked him to walk in a way that he neither goes uphill or downhill? Well, he only has two options. He can walk this way or he can walk this way, right? Either way, his height won't change. All right, so let's plot out what that path would look like. So say that he starts by walking this way, right? And he's going to go around the back of the hill. And he comes back around the other side and he ends up right back where he was. And this makes sense because he never changed height. Okay, so this curve that we just plotted right here is called the level curve, right? And so let's try to think of this in a more mathematical way and actually define what the level curve is. So the level curve is the set of values of this function that we have here, where the z value is fixed, right? Say that this z value right here, I don't know, is z equals 5, you know. And z equals 5 is actually some plane, right? If we were to graph what z equals 5 actually looks like. And the level curve is where this plane intersects with the paraboloid or whatever other function we were trying to find the curve of. If we move this plane up or down, we would get a different level curve. Say that we moved it up to, I don't know, say that this is z equals 7 up here or something. So now we have a different value that we're trying to find the level curve of. And say that that cuts the paraboloid right here. Now that's another level curve, except this time at z equals 7. And if we move downwards, we could make more level curves. So your level curve is just dependent on your z value that you set your function equal to, right? Now, say that this function is actually just some function of x and y, right? Well, then your z-axis is actually equal to f of xy, right? And so what you would be doing for these different level curves is you'd be setting f of xy equal to 5 in this case. And then for this other one, you'd be setting f of xy equal to 7. And as we change the value that we fix this function to, the level curve moves up or down. All right, so let's go back and look at what were the things that we were going to cover. So number one was we wanted to find the equation of the level curve. Okay, so let's start by just clearing up everything that we have here. And first off, we need to actually define what our function is. So say let's define this function as uh, let's define this function as we're going to do f of xy is equal to negative x squared plus y squared plus 8. All right, so uh, that would put our origin right here. And in fact, let's move coordinate system. Let's grab this. Let's move it to the origin to make things a little less confusing. Okay. So this is the function that this is a graph of. And we're going to find level curve at, I don't know, at, let's say, f of xy. Let's do f of xy equals 5. Why not? Okay, so it's very simple. All that you do is you set this equation here equal to this value. That's what we were doing. So uh, negative x squared plus y squared plus 8 equals 5, right? Subtract 8 from both sides and you get uh, x squared plus y squared equals 3. That's what it comes out to. Now, what is that a graph of? That's simply just a graph of a circle, right? A circle with radius of square root 3, right? So that would be, let's just guess and say that z equals 5 or f of xy equals 5 is around about there, that level curve. And that means that this radius right here, this is equal to the square root of 3. Okay, so far we've found the level curve. The next step was to find the normal vector given some point on the level curve. So let's start by picking a point on the level curve. Let's say that we pick, I don't know, 1 square root 2. All right. And that point should be around, let's say that it's right about there. Okay. Now, first off, what does a normal vector, what is it going to look like? Well, if we look at our graph from above, and I've drawn it here so the x and y axes are sort of similar to what we have here. If we look at it from above, and let's graph that point on here. Say it's about there. We got 1 square root 2. Well, a normal vector would be a vector such that it's perpendicular to the surface of the circle. right? Well, okay, how do we know what the sort of angle of the surface of the circle is? Well, you can sort of imagine the tangent line already going through that point. And the normal vector is going to, by nature, always be perpendicular to the tangent line. And it could be facing inwards into the circle, or it could be facing outwards. Both of these are perfectly valid. They both make 90-degree angles, right? And the normal vector could be of any magnitude, right? It could be really big. It still makes a 90 degrees. So this is sort of what we're looking for. Now, how do we find that? Well, in a previous video, we covered the topic of gradients, right? And what a gradient is a vector that points in the direction of steepest inclination, right? It's sort of like a compass, and it's a compass that only works on the XY axis, right? It just gives us a vector on the XY, but it points in the direction of steepest descent, right? So for this one, it would point sort of inwards like that, right? Because your steepest descent vector is somewhere up that way. That's as steep as you could go up. But this right here, this is your gradient, right? Now, it just so happens that the gradient is also always perpendicular to the function, right? So it should work just fine as a normal vector. Now, how do we find the gradient function? Well, we covered this in a previous video where we worked through some examples, but the gradient of f, right, overall for any xy point, right, is going to, is going to be the partial derivative of f with respect to x, and the y components can be the partial derivative of f with respect to y. And that's it. So let's write out what that's going to be. So for our particular f function, it's going to be, well, that's the only x term here. So negative 2x and then negative 2y. All right, so now we have that and we know what point we're looking for. So let's just plug our point into this function and find the gradient vector. So given the point that we're looking for, we have gradient function of 1 root 2 is going to be negative 2 times 1, which is just negative 2, and then negative 2 times root 2. And there you go. That's the vector. That right there is not, it's not a point, that's a vector. And that's exactly the vector that we're looking for. And if we were to draw what that vector looks like, it would look kind of like this vector that we have right here. You know, it's moving negative in both directions. Well, it'll look exactly like this vector that we have right here. This is the normal vector. Let's go ahead and label it then. And we'll go ahead and say that that is the normal vector right there. So just to review what we did to find the normal vector, we took the gradient, we found the gradient function of our initial function, and then we evaluated it at some point that was on the level curve, right, to find the normal vector for that point on level curve. And let's just bring all that up here and make it look somewhat neat. All right, so our last component that we're looking for is to find the tangent line equation. Now, what's the tangent line? Well, we already pointed out the tangent line. It's right here. And it's going to be perpendicular to the normal vector out of nature, right? Just by the way that it is. Now, to define a line, we need two things. We need either 2 points or a point and a vector, right? And in this case, we have a point and a vector. So let's write the equation for our line. First off, let's go ahead and state that P naught, right, our point, is equal to 1 root 2. And our vector is going to be, it's going to be the negative inverse of our normal vector. Right? If we negate our normal vector and then we take the inverse of it, then we get a vector that's going to be perpendicular to that vector. So what do I mean by that? So our vector, we'll call it V, is equal to the negative inverse of m. And our normal vector here, so basically all that we're doing is we're swapping each of these, and then we're negating one of them, right? So we get 2, 2, and then negative 2. That would work just fine. You could also do negative 2 root 2, negative 2, or positive 2, my bad. This would also work. That would also work just fine. Now, if we recall our line equation, the line equation is just y minus y naught is equal to x minus x naught multiplied by our slope. Call it m. Okay, so we have a y naught and an x naught. That comes from our p naught value. This is our x naught and our y naught values, right? But we don't have an m, at least not directly. But we can get it pretty easily from our vector, right? This is a vector that's along the line, and the slope is just rise over run, which is just your y value over your x value. So we can take this and we can say that m, from this, m must be equal to negative 2 over 2 square root of 2, right? And the 2's cancel out, giving you that m equals negative 1 over root 2. And we could put this in proper form, but I'm not going to waste your time with that. So then from all that, we get that from this and from this, we get that the equation must be y minus y naught, which is root 2, equals x minus x naught, which is 1, multiplied by negative 1 over 2. So we could do negative and then put it over root 2. And let's make that look a little bit more presentable. And there you have your final tangent line equation. And this is just the tangent line equation for this point specifically. All right, just to go over what we did for the tangent line. First, we found a point and a vector for the line, right? At the given point that we were given, the point we already know is just going to be that point. And then the vector was just the negative inverse of the normal vector, right? We just negated one element and then flipped the two to give us our vector along the line. Then we recalled our equation for a line, and the only thing we were missing was m, and we can get m from the vector by just dividing the y component by the x component. Then plugged everything in, and we got our equation. All right, so that's all three things that we set out to find: the level curve, the normal vector at some point on the level curve, and the tangent line at that point. If this is helpful to you, please leave a like and have a great day.